All right, this last question is actually pretty quick if you just take some time to think about what it is they're asking you. For part A, for this problem it says, consider the angles that a soccer ball is kicked as shown. So we have a soccer ball being kicked at angles of 80 degrees above the horizontal, 65, 45 right in the middle, 25, and 10 degrees. Now it's not drawn this way, but you should assume that each one of these vectors is the same resultant magnitude, because that's going to be important. So I'm just going to stretch these out to show that they are pretty close to being the same result magnitude. Now, if that is the case, I think we're in a position to answer the rest of these questions. What's going on here? Okay, whatever, 25. It wants to know which angle results in the greatest hang time. This question is trying to probe your understanding of what will affect what angle will have the greatest effect on the hang time of an object. If we're talking about the time that we're in the air, then we are always going to be talking about the vertical component. So right off the bat, I just want you to consider this 80-degree angle, which has horizontal component and a vertical component that kind of look like this. It is the vertical component that will determine how much time I'm in the air. The greater the vertical component of velocity, then the more time that I will be spending in the air. So the greatest hang time should be, given these choices, at 80 degrees. And think about it, if there were 90 degrees, if you could somehow pop a soccer ball straight up in the air at 90 degrees with the same velocity as all these other vectors, you should be straight up in the air, going, reaching the highest point and staying in the air for the longest. But that's only if each one of these magnitudes is the same magnitude. For question B, it wants to know which angle results in the furthest horizontal displacement. So as opposed to trying to find the greatest hang time, we want to find which one of these is going to get me downfield the furthest. Now, if you think about a vector that has horizontal and vertical components, moving downfield is really a two-person job. I've told you that the vertical and the horizontal velocities are absolutely independent of each other, and they are. However, the displacement horizontally, how far downfield this ball is going to go, depends on both the vertical and the horizontal displacement. It depends on the vertical because the longer that I'm in the air for, then that is more time that I'm going to be able to move downfield in the horizontal direction. So greater hang time gives me more time for my horizontal component to move downfield. But if this horizontal component isn't large enough, then I can have all the hang time in the world, but I may not be going very far downfield. So a 45-degree angle gives me the situation where the horizontal component and the vertical component are equal in magnitude to each other. At 45 degrees this occurs. And when these components are equal to each other, they offer the best balance of hang time, vertical component, and downfield velocity. The greater the downfield velocity, the faster I'll be moving in this direction, and the more hang time that I have, the longer I'll be moving in that direction. So it turns out that the angle of 45 degrees is going to give me the largest downfield displacement. And my 80-degree angle would be the least, and it turns out that my 10-degree angle also gives me the least. It ties with 80 degrees, which leads us to this very last question. It wants to know two angles that will yield the same horizontal displacement if the soccer ball is kicked at those two angles. What I want you to realize is that there is this mirror effect right about the 45-degree angle mark. Anything below or above it has a complement on the other side, meaning that in this case, if I am 20 degrees above 45 degrees, I'm going to have more airtime than 25 degrees, but certainly nowhere near the horizontal displacement, if you believe that this is a parabola. Certainly nowhere near the horizontal displacement that I would have at a 45-degree angle. And at a 25-degree angle, I got not as much hang time, but I got lots of downfield velocity, because now my horizontal vector for that 25-degree angle is more oriented in the horizontal direction. So it looks like this, but because I don't have much hang time, I end up hitting at the same spot as I did for the 65-degree angle. And similarly, for the 80-degree angle, I got tons of hang time, but not very much downfield velocity, so I end up hitting relatively close to where that soccer ball was kicked. And for the 10-degree angle, well, I have tons of downfield velocity, but not nearly as much hang time, so I'm not in the air for very long. They balance out. And it turns out that the 45-degree angle, if you neglect air resistance, is the angle that will give me the furthest horizontal displacement. If air resistance is a factor, then that means you would slow down at some rate, which means there would be some force acting on you in the horizontal or side-to-side direction. But if I had to write this out, I would say that 80 degrees and 10 degrees give me the same horizontal displacement, and I could also say that 65 degrees and 25 degrees gives me the same horizontal displacement. 65 is 20 above 45, and 25 is 20 below. 80 is 35 above, and 10 is 35 below. It all centers right around that 45-degree angle. That's pretty much it. That's all the stuff you would need to know. If you do this well, then you should be in good shape for your Unit 5 quiz on two-dimensional motion.